Hello, lovely people. Welcome back once again. So today we are going to talk about multiplication of matrices. How do you multiply matrices? Alright, so but before that, let's look at a topic called scalar multiplication, also known as a scale factor. So what is this factor or the scalar multiplication talks about? So let's see. So we talk about scalar multiplication. This is when a matrix is multiplied by a scalar. A scalar can be an integer, a number, a fraction, any. So in this case, let's have this example. We have K multiplied a matrix A, B, C, D. So we say K is a scale factor, or it is known as a scalar factor. So this K is multiplying the matrix. So when you simplify this, so we know K is multiplying each element in the matrix. So K multiplies A, K multiplies C, K multiplies B, and K multiplies D. So K multiplies A to get KA, K multiplies C to get what? KC, K multiplies B to get KB, and K multiplies D to get KD. So the scalar multiplication talks about a number multiplying a matrix. So when you multiply this scalar K to this matrix, this is what you're going to get. With this, let's try and solve this example. It says if matrix A equals 3, 6, 2, 7, B 12, 9, 18, 21, matrix C 2, 6, 4, 5. Find 2A. And B, find 1/3 of matrix B. And C, 5 times the matrix C, right? So let's see, let's try and solve the I. So with the I, it says 2 multiplying matrix A. So now we know our matrix A. So it's 2 multiplying this matrix. We have 3, 2, 6, and 7. So when you multiply this matrix, you are going to get, so 2 multiplies this 3, 2 multiplies this 2, 2 multiplies this 6, and 2 multiplies 7. So in this case, when you multiply 2 against 3, you're going to get 6. When you multiply 2 against 2, you're going to get 4. Sorry, 4. This time this gives you 12, and this time it gives you 14. So 2 multiplies matrix A is 2 times the whole matrix. So you multiply the element in the matrix by the scalar, right? Again, let's try and solve the II. The II says 1/3 of the matrix B. So 1/3 of the matrix B, we have 12, 9, 18, and 21. So means 1/3 of each element in the matrix B. So we're going to get 1/3 of this, 1/3 of that, 1/3 of 9, and 1/3 of 21. So when you simplify, 1/3 of 9 gives you 4. 1/3 of 18 gives you 6. 1/3 of 9 gives you 3. And 1/3 of 21 gives you 7. So this is the result. Multiply 1/3 of the matrix B. So 1 out of 3 multiplies 12. 1 out of 3 multiplies 18. 1 out of 3 multiplies 9. And 1 out of 3 multiplies 21. They're going to get 4, 6, 3, 7. Okay, so now let's try and solve the C. That's 5 multiplying the matrix C. So we have 5 multiplying the matrix C, 2, 4, 6, and 5. So as usual, the scalar will multiply each element in the matrix. So we have 5 multiplying 2, 5 multiplying 6, 5 multiplying 4, and 5 multiplying 5. So you are going to get 10, 20, 30, and 25. So when you multiply 5 by the matrix C, this will be your result. Hello. So we are going to learn how to multiply matrices. As usual, matrix has a rule. So in this case, we multiply matrices of the same size. We already know what a size means. So when we look at this example A, this matrix A has A, B, C, D, and this matrix B has P, Q, R, and S. So we can see that matrix A and B have the same size. If I may ask, what is the name for this matrix? How will you describe this matrix? This matrix A is called a 2 by 2 matrix. And this matrix B will also term as what? A 2 by 2 matrix. So you see that we can multiply two matrices of the same kind. So this is a 2 by 2 matrix and this is a 2 by 2 matrix. So let's see how we multiply 2 by 2 matrix. So now we are going to talk about the multiplication of what? 2 by 2 matrices. How do we multiply 2 by 2 matrix? So let's say this matrix A has the element A, B, C, and D, and matrix B has the elements P, Q, R, and S. So we should multiply A times B. Matrix A times the matrix B. So how do we multiply? We will do that using the row and column. All right. So I know still remember what a row is and what a column is. So we're going to use that idea to multiply the matrix. So A times B is giving us what? A, and multiplying this matrix B, P, Q, R, and S. So how do we multiply such matrices? All right, so we are going to use the idea of rows and column. So this is what you do. You consider the first row in the first element. So the first row in A multiplying the next column in B. So the first row in A multiplies the first column in B. So this is the first row in A, and this is the first column in B. So the first row in A multiplies the first row, the first column in B. So this multiplies P. So we're going to get A times P. And what separates them is plus. Plus this multiplies this. So we have C plus Q. I take it again. A multiplies P. So the first row in A is multiplying the first column in B. So A multiplies P, giving us A times P. And plus C multiplies in Q. C is multiplying Q. C multiplies Q to give you C times Q. C times Q. All right. So the same thing, the second row in A multiplies the first row in the first column in B. So the same thing, this B multiplies this P. So B times P, right? Plus this D multiplies this Q. D times Q. So you are done with the base. So you move on to the next row and the next column. So this one, the same row will multiply the next column in B. So the first row in A multiplies the second column in B. So A multiplies R. You can get AR plus C multiplies S. Then you get C multiplies S, right? So when you come to the basement, we have B, D multiplying R and S. So B multiplies R to what? B times R plus D multiplies S to be D times S. So when you multiply these two matrices, this is what you're going to get. I go over again. When you're supposed to multiply A and B, you consider the first row in the first matrix and the first column in the next matrix. So here, the matrix A, the first row is A and C. So that's the first row in A. And I'll consider the first column in B, that's P and Q. So now I'll multiply each element. So A multiplies P, getting A times P here, plus C multiplies Q, you have C times Q there. We are done with the first parts. The first part, you move on to the down, that's the base. You have B, D, that being the second row in A, and you multiply it against the first column of B. So that's B times P, getting B times P here, plus D times Q. Then it follows the same pattern. Okay, so now let's have this example. Example says if matrix P equals minus 2, 3, minus 4, 5, and matrix R equals 1, minus 3, 2, 7. Find P times R. So matrix P multiplying matrix R. So what is a matrix P? We have minus 2, 3, minus 4, 5. Multiply your matrix R. We have 1, minus 3, 2, 7. So when you multiply these two matrices together, as usual, you consider the first row in the first matrix against the first column in the next matrix. So you're going to get minus 2 multiplying negative 1. So minus 2 multiplies 1 plus minus 4 multiplies minus 3 here. When you're done, the same matrix in this base multiply the same column. So this row 2 multiplies column 1 of this base. So I have 3 multiplies 1 plus 5 multiplies minus 3. When you are done, you consider the next column as the column 2. So the column 2 is the same thing. The first row multiplies the second column there. So you're going to get minus 2 multiplying 1, minus 2 multiplying 2, plus minus 4 multiplying 7. Are you with me? And you come to the basement of this. So we have minus 3. We have 3 multiplies 2. So 3 multiplies 2 plus 5 multiplies 7. So when you simplify, you're going to get minus 2 plus 12. Here, you're going to get 3 minus 15. So 3 minus 15. And here, you're going to get minus 4 minus 28. Minus 4 minus 28. And here, you're going to get 6 plus 35. So 6 plus 35. So when you further simplify this, you're going to get minus 2 plus 12 gives you 10. 3 minus 3 gives you minus 12. This gives you minus 32. And this gives you what? 41. So this is the answer when you multiply P by Q.